Welcome to our first episode of the first chapter of the Geodesy subject. So in this presentation, a brief history and development of geodesy will be discussed and also definition. So before we proceed, may I present to you first the objective of this topic. So at the end of this lecture, you should be able to define what is geodesy, identify the basic concept of geodesy and different application of geodesy in relation to our profession, and discuss the short history and its development. So let's start with the historical beginnings of geodesy. During the Greek era, so this geodesy is the most challenging disciplines during this period. So they have here, wala pang mga instrument na mas advanced to determine what exactly the shape of the earth. So many philosophers propose theories on what should be the shape of the earth. So we have here on the illustration, we have the flat disk, the flat earther, that is proposed by Thales of Miletus. He is the founder of trigonometry. He thought that the Earth is a flat disk floating in an ocean. We have another proposal. This is from Pythagoras. So he was the first to believe that the Earth is in shape of the sphere, or spherical. And then we have the cylinder. We have Anaximander of Miletus. So he proposed that the shape of the Earth is cylindrical. Another, we have Heraclides. He proposed that the Earth move around the Sun and spin around its axis. So we have here also Aristotle. He formulated the first plausible argument of the sphericity of the Earth and the first hint of the possibility of the gravity exists on the surface of the Earth. So he then calculated and proposed that the distance around the Earth, it should be the circumference of the Earth to be 45,500 miles. So this man here, he is Eratosthenes. He is the one who first determined the size of the Earth. So how did he determine the size of the Earth? So I have here the illustration what he did in measuring the circumference of the Earth. Okay, at first, he measures the wall in Alexandria, you have here, and the shadow cast by that wall. So in these values, he can determine the value of the angle between them, which is the z. So he then measures the distance between two places in which we have the wall in Alexandria up to the wall in Sinai, which is about 800 kilometers. After he measures that one, that angle also is the proportional length of the center of the earth is proportional to the length of the wall of Alexandria. So that which means the value of z cast in the shadow is similar to the angle of z at the center of the earth. So he used this formula circumference equals to r theta. You are familiar with this formula in which the r is the radius of the earth and theta is the value of z or the angle subtended by that light rays. So he calculated the circumference of the Earth is about 40,000 kilometers. That would be the circumference of the Earth. During the 14th century, so they started with the Great Navigation. So these are the famous navigators. We have uh, Columbus, who navigated the Atlantic in the year 1942. We have Vasco da Gama and Ferdinand Magellan, who is the one also proved that the Earth was sphere. So the expanding geographical knowledge prompted the new growth of new profession, which is the map making, or also known as the cartography. So in the 15th century, we have the century of thinkers. So we have also philosophers who published their theories. We have Nicholas of Cosa. He wrote about the general motion of the Earth and introduced the idea of infinite universe. We have here the next we have Copernicus, who established the heliocentric theory. So this theory introduces that the Earth revolves around the Sun. We have Dutchman Snell, who carried out the first accurate triangulation and made the first rigorous study of refraction. So when you say triangulation, I have here. So the concept of triangulation, diba? So we are going to measure the angle to determine the unknown position. So this is the photo of the first triangulation made in the rigorous study of refraction. Another we have Picard, who made the first modern measurement of the Earth. So he measured the meridian arc length through Paris. He was the first man to use the telescope with crosshairs and obtain the radius of the Earth, and aided the concept of Newton and the shape of the Earth, which is a spheroid. Have you another? Huygens, he discovered the first accurate timekeeping based on the use of pendulum, and the most important here is the era of Newton and his law of gravitation. So Newton also proposes that the shape of the Earth is in oblate spheroid. I have an illustration, but this proposal of Newton what was not been approved by Knight because he has an opponent. We have here Cassini. So the proposal of Newton is the shape of the Earth is somewhat in oblate spheroid, which is flattened at the poles and bulging at the part of the equator. So Newton raised the discussion on the figure of the Earth by the physical model of the ellipsoid, by the use of the flattening of the Earth and its rotation at the poles. But how about Cassini naman? So he proposed that the shape of the Earth is a prolate spheroid, so somewhat flattened at the equator opposite kay Newton. So to determine which proposal is correct, so some astronomers conducted a triangulation, so they measure the meridional arc to determine which is longer. We have here either prolate or an oblate spheroid. So we have here an expedition to measure the meridional arc. So some astronomers measure the meridional and some of them measure the equatorial. So we have here the Finland expedition led by the Maupertuis. So they measure the meridional arc in the equatorial mission to prove which uh, what is the actual shape of the Earth. According to Newton, so if our Earth were not little higher at around the equator than at the poles, the seas would subside at the poles and by ascending in the region of the equator would flood everything there. So that is impossible. So he opposed the shape that was proposed by Cassini. So pag longer ang ating poles, the water would come down and it would be flooded at the equator. So it would be impossible. So after the work of Picard and the other French expedition using the triangulation, so the work on the triangulation becomes broadened. So the instrument needed for triangulation, example, we have here the theodolite, the tapes, were becoming more accurate at this time. So easier to operate and more portable. We have Gauss naman, so he defined the geoid. When you say geoid, that is the true shape of the Earth with respect to topography and gravity, and invented the least squares, which is what we're using to eliminate the errors in our measurement. So his work on the theoretical foundation of geodesy has caused some geodesists to claim that he is the father of geodesy. We have also Basil, so he determined the first accurate figure of the flattening of the Earth from existing knowledge of the geodetic position. So on the next topics, we are going to determine what is this flattening of the Earth. Okay? By this time, the use of triangulations are widely used. So when we say triangulation, again, this is a method of determining the position of a fixed point by measuring the angles. So from two fixed points, so which is from known distances. Okay? So in the modern era, nag-expand na yung mga measurement na ginagamit, and the method and the equipment used in measurement is also expanding. So I have here is some example of the modern instrument. We have here the radar, which is commonly used for weather forecasting. We have another for commonly meron na tayo ngayong mga electronic computer to analyze data. We have the EDM used in polarized light and radio wave, which is found in our total station, and the lasers have also the radio astronomy, so led by discovery of the pulsars and quasars. Another, we have launching of the artificial satellites. Marami for now, ang dami nating mga artificial satellite system. inertial navigation and positioning system. Example natin ay the global navigation satellite system with the use of the GPS, the use of the Galileo, GLONASS, and some of the navigational system found at the uh, above the Earth. So I have here, when we say GNSS, I have here some of the point on the GNSS. So when you say GNSS, that is the Global Navigation Satellite System. So the increase on ease and accuracy by which geodesists could determine the position as well as the gravity field parameter ng ating Earth. So it leads to a new application as well as the new problem. So suddenly the effects had always been considered negligible. Hindi siya negligible and nagsa-start na pag-show up yung mga noise or yung mga problem. So, one of the one's noise is being one of the other signals. So, marami ng questions about what is this gravity, the shape of the Earth, what will be the connection of the Earth and the gravity. So, we have here some of the revolutionized geodesy and surveying. We have the International Terrestrial Reference System. We have the GNSS technology, the development of the geoid, the geodynamics, when we say movement of the Earth's crust. With respect to the gravity, we have the gravity mapping. Sobrang expanded na yung coverage ng ating measurement system. So, the geodesy, from start na lang, yung geodesy is basically started with the measurement. Simple measurement. Then, it comes up with determination na ng true shape ng Earth because we are dealing with measurement. No, hindi lang tayo nagme-measure ng plane distances. We are actually expanding on the measuring actual shape of the Earth. So, on the next presentation, we are going to determine now or identify what will be the definition of the geodesy. So, how did the geodesy word term geodesy came up into action? So, see you on the next slide, continuation of this presentation. So, for the modern geodesy, so, the ating modern na geodesy na, so, yung una is triangulation lang. So, the modern geodesy is no longer the stereotype of what many people learn at the schools. No, kung natin nalalaman. So, where they talk about the geopotential theory and the gravity modeling. So, now, we are modeling the Earth in four-dimensional with respect to X, Y, Z. And the third one is the four-dimension, which is the time. So, modern geodesy is about the 4D mapping, as you can see in this illustration, in place of the 3D. So, it's about continuous mapping of the solid Earth, the ocean. It's about increasing the spatial resolution. We say spatial resolution, that is the amount of clarity or example sa yung photo, and accuracy, increasing reliance on the infrastructure and services. So, very wide na yung coverage ng ating geodesy. So, medyo hindi lang natin na napapansin because when I say geodesy, the term is being used commonly lang sa mga na field na related kay geodesy. But this geodesy is very wide in area, very wide in idea. So, let's define geodesy in the next presentation. So this will be the end of this lecture, the history of geodesy. Again, the next presentation will be on the definition. So stay tuned on this presentation.